preparing for launch projects. It is the year 2122 and the Earth's resources have been drastically depleted in the past 100 years. The President of the United World Council has authorized you and your crew to proceed with the Mars mission. You will put the most advanced spaceship the world has ever known, the Excelsior. It will carry terraforming equipment and 200 colonists to begin making Mars habitable for human life. Before the mission can launch, a few items need to be figured out. What is the capacity of the fuel tank? How long should the fuel burn to achieve escape velocity? Otherwise, the Excelsior will be stuck in the Earth's gravitational pull. How long will it take the Excelsior to arrive at Mars? Figuring out the first item, what is the capacity of the fuel tank? The ground crew is filling the fuel tanks. You know they fill the tanks at a rate of R equals 100 e to the power of t, where R is measured in tons per hour and t is measured in hours. They fill the tanks for 2.5 hours. Calculate how many tons of fuel are in the tanks. Once they are full, rounded to the nearest ton. Figuring out the second item, which is how long should the fuel burn to achieve escape velocity? You know the Excelsior must achieve 30,000 pmh to reach escape velocity. The rocket's engines are state-of-the-art and capable of creating an acceleration based on a profile A equals 10t, where t is in seconds and a is in ft over s squared. Unfortunately, the pull of gravity works against the rocket's motion at 32 ft over s squared, neglecting wind resistance. Calculate how long to burn the fuel to allow the Excelsior to achieve 30,000 mph rounded to the nearest minutes. The straight line distance from Earth to Mars at the time the launch is scheduled is 100 million miles. In order to avoid other celestial bodies, the Excelsior must travel in an arc given by the equation y equals -1 over 125 x minus 50 squared plus 20, where x and y are in millions of miles and the x-axis denotes the straight line distance to Mars. Find the actual distance traveled by the Excelsior rounded to the nearest million, and then find the approximate time for the trip rounded to the nearest month, assuming a constant speed of 30,000 mph and 30 days in each month. Points awarded in the following way. 70 points: solve the problems independently, show all the required work. No work shown, no points. 30 points: create videos to solve the problems, 10 points for each. Especially difficult equations or integration can earn up to 5 bonus points. Late projects will lose 2 points per day, including weekends. Good luck.